When you think of an offshore oil rig, you probably picture this huge metal island sitting way out in the ocean. But you know what? What we see above the water? That's just the tip of the iceberg, literally. We're about to dive into the absolutely incredible world of these offshore structures, true marvels of engineering, hidden in plain sight, with a story that stretches for miles straight down.
And just to give you an idea of the scale we're talking about, think about this for a second. Some of the tallest structures ever built by humans aren't skyscrapers in Dubai or New York. Nope, they're out in the ocean, and almost all of their immense height is completely underwater. Kind of mind-blowing, isn't it?
And this chart really drives that point home. Just look at the Perdido platform. It's operating in water that's 2,450 meters deep. That's almost 3 times the entire height of the Burj Khalifa. And that incredible depth, well, that is the single biggest challenge for engineers, and it shapes every single decision they make.
So how in the world do you build something like this in the middle of the ocean? Well, the simplest way is to do what we do on land. You start from the ground up. So for the relatively shallow waters closer to the coast, engineers can actually build structures that are physically connected right to the seabed.
And this is what we call a fixed platform. The idea is pretty straightforward, right? You build a massive steel or concrete tower with legs that are piled directly into the seafloor. Being anchored like that makes them incredibly stable, perfect for fighting off wind and waves. But as you can probably guess, there's a limit. Building legs that are thousands of meters long just isn't possible from an engineering or a financial standpoint.
So even in this fixed category, you've got a couple of different flavors. On the left is a jacket platform. It's a permanent steel structure, kind of like a cage, that's built for long-term production. We're talking years and years. On the right, though, that's a jack-up rig. It's mobile. It gets towed to where it needs to be, drops its legs down to the seafloor, and then it literally jacks up its main body out of the water. This gives it a super stable place to work for drilling or repairs, and then it can pack up and move to the next job.
So the key takeaway here is, if the bottom is close enough, you can just stand on it. You can build something permanent for production, or you can bring in something mobile for temporary jobs. But what happens when the water gets so deep that the seafloor is thousands and thousands of feet down?
Yeah, as the search for resources pushed everyone further and further from shore, just standing on the bottom was no longer an option. This is where things get really creative. It forced engineers to invent completely new ways to work on the ocean by mastering the art of floating, but floating with extreme stability.
And this image, wow, this just perfectly illustrates that whole journey out to sea. See on the far left? Those are the fixed platforms we just talked about, chilling in the shallow water. But as you move your eyes to the right into deeper and deeper water, you see this incredible evolution of floating designs. Each one of them is a totally unique solution to the problem of working way out in the open ocean.
And these are the big 4, the main families of floating platforms. Each one is just an ingenious way to solve the problem of stability. You've got the semi-submersible, the tension leg platform or TLP, the SPAR, and the FPSO. They all have different tricks up their sleeves, but the goal is the same: stay steady in a chaotic environment. How they do it? Well, that's where the engineering magic really happens.
All right, now we're heading into the final frontier, the ultra-deep ocean. We're talking about some of the harshest environments on the entire planet. And out here, you find the most impressive feats of offshore engineering. We're going to look at 2 of the heavyweights, the semi-submersible and the SPAR. Okay, the semi-submersible is so clever. It's got these massive, buoyant hulls down at its base. What they do is flood them with water, which makes the whole structure sink lower in the ocean. This puts most of its mass way below all the choppy, chaotic waves on the surface. It basically disconnects the platform from the surface weather, creating this remarkably stable workspace up top, even when the seas are really rough. And here's a perfect real-world example. This is the Amaechi platform in the Gulf of Mexico. It's a modern semi-submersible, and it's working in over 2,000 meters of water. I mean, just look at the size of those support columns. It's a true testament to how ridiculously advanced this technology has become.
Next up, we've got the SPAR. The easiest way to think about this one is like a giant fishing bobber. It's this massive, single, hollow cylinder that goes way, way down into the water. So most of its weight is far below the surface, which gives it a super low center of gravity. And what that does is it makes it so incredibly stable that even as huge ocean waves roll by, the platform on top barely even moves.
And you can really see how fast this tech evolved right here. It all started with the first SPAR, the Neptune, back in '96. From there, engineers just kept pushing the design.
They built Perdido to work in some of the deepest waters anywhere on Earth. And then they built Aasta Hansteen, the world's largest, specifically to handle the absolutely punishing conditions of the North Sea.
Okay, so we've seen how decades of amazing innovation took offshore engineering from the shallow coast all the way out into the deepest parts of the ocean. But, the story doesn't end with oil and gas. All of this hard-won knowledge is now being put to work on a brand new, very urgent challenge.
And this is where the past meets the future. The next big wave for these ocean giants is in renewable energy. Specifically, we're talking about floating offshore wind farms that can capture the super powerful and consistent winds that are found way, way out at sea.
Now, do these designs look a little familiar? Because they absolutely should. It turns out, to build wind turbines in deep water, which is where the best wind is, you need floating platforms. And the leading ideas are, you guessed it, SPARs, semisubmersibles, and tension-leg platforms. The exact same technologies that have been perfected by the oil and gas industry for the last 50 years.
In fact, if you look at the floating wind projects that are in the works right now, that familiar semi-submersible design is expected to be used in about half of them. This isn't just inspiration, it's a direct technological inheritance. We're taking a proven solution forged over decades and just applying it to a completely new problem.
And here is exactly why this matters so much. A staggering 80%, 80, of the world's best offshore wind is blowing over water that's just too deep for those traditional fixed-bottom turbines. So these floating platforms, they're the only key we have to unlock this absolutely massive source of clean energy. Without them, most of the ocean's wind power would just be totally out of reach.
So all of this leaves us with a really fascinating question to think about. We've gone from platforms standing on the seafloor to these immense floaters that have mastered the deep ocean. As we engineer our energy future, will these giants of the ocean, originally born from our search for fossil fuels, actually become the very pillars of a new, renewable world?